3.2 Introduction to Functions. So we're going to define a relation, domain, and range. So a set of ordered pairs is called a relation. The domain of the relation is the set of x coordinates, or the first of the ordered pair. The range is the y, so it's the second. We're going to determine the domain and range of the relation. So domain, that's all your x values. So we have 4, -4, 2, and 10. So with our little brace, we have 4, -4, 2, and 10. Order does not matter, thankfully. For our range, it's all the y values. So all the y values, we have 9. We have 9 again, but so we don't write it twice. We have 3 and -5. So that is our domain and range. Now let's find the domain and range of the following relation. So we have input animal and output lifespan. So input, that's your x, always, because isn't that what you plug in? And your output is y, because that's what you get out. So for our input, our domain, that's all our x values. We have polar bear, so I'll put PB, cow, chimpanzee, CH, giraffe, I'll put GF, gorilla, I'll just put GR, kangaroo, I'll put K, and red fox, I'll put R. See how I did it for what it worked for me? You could spell it out if you want, you can abbreviate it, it's up to you. It's multiple choice, or it's not multiple choice, but yeah, for this it'll be multiple choice in your homework and stuff like that, so you don't have to write it out. Alright, so for our output, our range, it's all of our y values. So we have 20, 15, 10, and 7. We don't care about the arrows, we just write the numbers. Identifying functions. So some relations are also functions. A function is a relation in which each first component in the ordered pair corresponds to exactly one component. So what the heck does that mean? No repeating x values. So as long as x is different, it's a function. It has to be different though. So let's look at all of our x's. We have 4, -4, 2, and 10. None of those are the same, so no x values repeat. Since that's the case, it is a function. So is it a function? Yes, it's a function. So let's go ahead and do the same thing. Let's determine whether each relation is the graph of a function. So what I like to do is label my points. So my first point here, that's -2, 1. My next point, that's 3, 2. And my next point, we have 3, -3. So again, we just look at our x's. We have -2, 3, and 3. We have repeating x's. This is not a function. So 3 repeats. Since that's the case, this is not a function. Alright, I want you to go ahead and pause it and do B. So for B, let's label our first point. We have -2, 1. We have 0, 1. 3, 2. And 1, -3. So now that we have all of our x's listed, let's go ahead and look at them. So -2, 0, 3, 1. None of the x's are the same. So none of the x's are the same. Since that's the case, this is a function. So I'm going to say yes, it is a function. Another way we can determine that graphs are a function is using the vertical line test. If no vertical line can be drawn so that it intersects a graph more than once, the graph is the graph of a function. Meaning, this is the one where you do the vertical line thing. I hate the way that looks though. So I like to use my ruler or piece of paper. So using my ruler, you see how I go across the red line, how it only touches it once? No matter what, it's only touching it once. So this is a function. I would do the same thing to the next one. So as my ruler goes across the red graph, you see how it only touches it once at a time? So yes, this is a function. It's a weird function, but it is a function. Alright, last we have our circle. So see how I go across the circle and it's touching the red twice? Here, here, I mean literally everywhere. It's touching it twice. This is not a function. Finding domain and range. So let's find the domain and range of the function graphed to the right, and we're going to use interval notation. So our domain and range, so remember our domain, those are our x values, and our range are y values. Let's label these points. That first point to the left, that's -3, 2. The bottom point to the right is, it's a little hard for me to see, 1, 2, 3, 4. It's 4, -4. On my paper notes I say 5. Alright, anyways, it's 4, -4. So what we want to do, since there's no arrows, it has a start and a stop, and we're going to use interval notation. So for interval notation for any domain and range, it's going to be, so for domain, it's smallest x and biggest x. For your range, it's the same thing. It's the smallest y and the biggest y. So if we did that, our domain, our smallest x is -3. It's the point we're given. And the biggest x is 4. That's the point we're given. Our range, our smallest y is -4, and our biggest y is 2. And those are from the points that they gave us. Alright, next we have another function. It's an absolute value because it's a v. So you see how we have double arrows that go up or down? Double arrows that go double up or double down, your domain is always going to be all real numbers. So the reason why it's all real numbers, because it's going up and out. So put your arms straight up and start bringing them out. See how it's forever going towards the x's? That's why the domain is all real numbers. And that is for every graph that has double up So for our range, it's a little different. For our range, so our range, since we have double arrow, whenever you have double arrows, your range, since it goes up, so if we have double up, the range is going to be smallest y to infinity. If it's double down, your range will be -infinity to biggest y. And it is a bracket because it's all included. Sorry, it's a bracket. So since this is double up, our smallest y, our point here, that point is 2, -2. So our smallest y, we have, it's double arrow, so -2 to infinity. Function notation. So function notation is f of x. So when we want to denote y as a function of x, we can say y equals f of x. F of x, w of k, blank of blank. That's what you're looking for. It's blank of blank. When you see that, you're talking about a function. So it's the same. Your x is the independent variable. Your y is the dependent variable, because your independent, that's your input. Your dependent is your output. Find each function value. If f of x equals 4x minus 1, find f of 2. So f of 2, that's the same kind of notation of f of x, right? That's where x is supposed to go. So that's telling us that x equals 2 and to plug it in. So f of x, that's just the same thing as y. So I'm going to switch it to y. So we have y equals 4 times x, which is 2 minus 1. So 4 times 2, that's 8. 8 minus 1, we get 7. We have to write our answer in a fancy way, though, because they ask it in function notation. So we say f of 2 equals 7. Meaning we plug in 2, we get 7. For b, if g of x is x squared minus 2x, find g of -3. So now we're given x is -3, and we're going to plug it in. So g of x, that's the same thing as y. So we have y equals x squared, and x is negative 3, minus 2 times x, and x is negative 3. So let's go ahead and simplify this. We have negative 3 squared is 9. Negative 2 times negative 3 is 6, and 9 plus 6, we get 15. So g of negative 3 equals 15. Given the graph of the following function, find the values of each. So you're supposed to not see all this, but it's not whited out. That's fine. We'll just go over it. So this is what we're given. That's what we're given. So we're given x. So we're saying x equals 5. So x equals 5, let's go to there. So 1, 2, 3, 4, 5, and I'm going to go up. And that point is 1, 2, 3, 4, 5, 6, 7, 8. So f of 5 equals 8, because that's our x, that's our y. F of 4, so let's go to 4. So 1, 2, 3, 4. Let's go find that point. So the point is right here. So that point is at 3. So this would be 4, 3, or f of 4 equals 3. Remember, x, y. So here we have f of negative 5, so x is negative 5. And now, since we're here, we need to find the point that's associated to that. So the point is right here. So that's at negative 1. So that's negative 5, negative 1, or f of 5 equals negative 1. And the same thing for negative 6 and negative 7. The value of an export to a country A in billions is approximated by the function e of x equals 2.1x minus 1.55, where x is the number of years since 2000. Find and interpret e of 7. Estimate the value of exports to the country B in 2019. All right. So e of 7, we're saying x is 7. Here, it says x is the number of years since 2007. Or excuse me, it's the number of years since 2000. I always do that. So we do 2000 plus 7, and that's 2007. So that's what it means, that in 2007, the country exported blank billions of product. We can find the blank by plugging in 7 for x. So we have e equals 2.1x, which is 7, plus minus 1.55. Use your calculator. So 2.1 times 7 is 14.7 minus 1.55. So we get 13.15. So 13.15 billion worth of goods, sorry. Billions, let's put dollars. Estimate the value of the exports to country B country A, my bad, in 2019. So we're now in 2019. So 2019, that is how far away from 2000? That's 19 years, right? Isn't that 19 years away from 2000? So 19 years away from 2000. So we subtract them. So x is 19, because x is the number of years after 2000. So we just plug it in. We have e equals 2.1 times 19 minus 1.55. We use our calculator. So 2.1 times 19 is 39.9, and 39.9 minus 1.55, and we get 38.35 billion. So in 2019, the country exported $38.35 billion of product. Product to goods doesn't matter.